Everyone is hearing me, right? Hello?
Yes, sir. Yes, sir.
All right, so finish writing off the first question. All right, so that was for 3A. All right, so that was the first question. First question was for 3A. Any questions, by the way? Any questions? Because probably some person has said, oh, 3A is so simple. So remember, 3A is just multiply each term in the, or each element in the matrix for A by 3. So 3 times A, 3 times B, 3 times C, 3 times D. And you would get 3A. So remember, you're going to use this again, so that was just, now, going to just erase everything. So the next question we have is, now B inverse, matrix B is 5, 3, 3, and 2. So to determine B inverse, remember the inverse of a matrix is equal to 1 over its determinant divided by its adjoint. So the first thing we have to find is the determinant of B, which is AD minus BC. So remember, E, this is C, and this is D. So A is 5, D is 2, so it's 5 times 2 minus 3 times 3, D times C. So this is going to be 10 minus 9. So B, ADA for short, is, remember, you're going to switch the values in the leading diagonal. So you're going to have 2 up here, 5 down here, and for the minor or non-leading diagonal, they're going to change the negative. So negative 3, negative 3. So what we're going to do now for the inverse, B inverse. So remember, it's 1 over its determinant, 1 over. So 1 over 1 is just 1. So we could just write 1 times the adjoint, which is 2 minus 3 minus 3 and 5. And 1 times anything is the anything. So B inverse is just 2 minus 3 minus 3 and 5. Everybody gets that? Everybody understand that? All right, so just write it off for me. I remember, because the board space kind of limited, you would just continue. You should be continued underneath this. Everybody get that? So when you write it down in the book, just continue it underneath. Because I remember today in class, Mr. Sir, as students or something, I hope they know they're online. We are going to a circle theorem today. Because that's the next thing. We need to learn how to take notes off a board. Now, I go through one question today in a circle theorem, and I explain the whole concept of cyclic collateral. And I draw the big over thing on the board like this, and I show them that for it to be a cyclic quadrilateral, all the vertices of the quadrilateral should be touching the circumference of the circle, just like that. I see the student draw the circle. Well, I didn't really see the student. I checked the student book, and I see the student do something like this. No, that is nothing compared to what I have on the board. So now I have to make sure so we're not take off and take off correctly. Get what I say?
Sanamard,
Yes, miss.
can you please go through it one more time for me?
Yes, miss. So you want me to start over?
Understand up to the point of B inverse equal 1 over B times adjoint.
All right. So I'm going to do.
Nine.
I'm going to do it over, but I'm going to try and write a bit smaller so that everything can basically fit in order. So B. So with the past paper question, it says B is, what is it again? B is 5, 3, 3, and 2. And so we're supposed to find B inverse. Now, B inverse is equal to 1 over the determinant for B multiplied by its adjoint. Get that?
Yes, sir.
Now, first thing we have to calculate is the determinant. Now, determinant is calculated by the formula AD minus BC, which is equal to, as I said, the element in the matrix. This value is A, this one is B. The person with the noise in the background, could you put your mic on mute for me? And all students, keep your mics on mute unless you're asking a question. All right, so this element is A, this one is B, this is C, this is D. So we have 5 times 2, 5 times 2 minus 3 times 3, 3 times 3. Because remember, A is 5, B is 2, B is 3, C is 3. So basically, it's the minor diagonal, the product of the leading diagonal minus the product of the non-leading diagonal. That is basically what we have here. Equal to 10 minus 9, which is equal to 1. So that would be the determinant for B, matrix B. Next thing we need is the adjoint, as in ADJ for short. So the adjoint, what you would do is for the leading diagonal, the A and D, you're going to switch the values. So you're going to put 2 where the 5 is and 5 where the 2 is. So you're going to have 2 and 5. And for the non-leading diagonal or minor diagonal, you're just going to change the signs and the values. So if the 3 was negative, you change it to positive. But if you realize that both of them, they're negative, they're positive, so you just change both of them to negative. So minus 3, minus 3. Now to conclude, what we're going to do, we would usually put 1. Just write this, B inverse. So B inverse, therefore B inverse multiplied by the adjoint, which is 2 minus 3, minus 3, and 5. But as I said, 1 over 1 is just 1. So and 1 times anything is just same thing. So we're going to have 2 minus 3, minus 3, and 5. So that would be the inverse for the matrix B. All right. So all students, yes, miss?
How do you know the leading diagonal from the other?
The leading diagonal from the other one. All right. So this one, so it forms an X. You realize it forms an X now in a sense?
Yes, sir.
Yeah, the one that comes to the right hand side at the bottom here would be the leading diagonal. And the other one at the top here would be the minor or non-leading diagonal.
Minor.
Get that?
Thank you.
Like that. All right, so I'm going to continue. So remember, we're going to need all of these information. So the first thing we had, so let me remove this. Everybody finish with the board?
Yes, sir. No.
All right.
Wait a bit, sir, please.
All right. So this is a May 20, 2007 past paper question. It was valid at 7 marks for the entire thing. So we just finished the first 2. So we have 2 part to the question remaining, then we move on to another question. So remember, we're just continuing from Sunday with the past per questions. We can move on to matrix, to vectors after we finish with the with this tomorrow. Is it Thursday, Friday? Tomorrow evening will
Yes,
be
sir.
for Friday evening. So every Friday evening, there's multiple choice I work until the exam. Okay.
Okay, sir.
Yeah.
Okay.
So on Fridays we are gonna work
Same
multiple
time.
choice. Yeah, man. Same time, 5:30 between that time. So on Thursdays and Sundays we'll just work with the written paper, just pass back questions. And on Fridays we do multiple choice. So as you can see, I did I send some multiple choice in the WhatsApp groups. I think it was what from 2014 to 2019. Yeah. So we're going to go through all, even though the answers are marked, we're going to go through all the questions so that each person can understand. Hmm? Oh yeah, man. Is it Ben? No, you said when we finish. Yeah. All right. So everybody's finished the board now, right?
Yes, sir.
All right. So let me remove this. Now the next part of the question. So we're supposed to determine 3a plus b inverse. Now 3a. So recall 3a. 3a was equal to 3a, 3b, 3c, and 3d. That was 3a from the first question. The second question, we had b. We were supposed to determine b inverse, and b inverse was equal to, what? 2, 5 minus 3 minus 3. So this is what they want us to do, the sum of 3a plus b inverse. Now 3a is 3a, 3b, 3c, 3d plus b inverse, which is 2 minus 3 minus 3 and 5. So when we are adding matrix, we add the corresponding values, right? We add the corresponding values. So remember, this represents the first element here represents A, second element represents B, third element represents C, and the fourth element represents D. And it's the same thing for this matrix. So the first element is B, the first element is A, second element is B, third element is C, and the fourth one is D. So we're going to add A with A, so it's corresponding terms. So what we're going to have, 3A plus 2, so it's 3A plus 2. That's for the first element in the matrix product, 3A plus B inverse, 3A plus 2. For the second element, we're going to have 3B plus minus 3. But positive, negative, which one is stronger? Negative, so we'll just put minus 3 there. For the third element, we're going to have 3C plus minus 3. So we're just going to have 3C minus 3. Then for the fourth element, we're going to have 3D plus 5. So it's 3D plus 5. So that's our solution for 3A plus B inverse. Any questions? Any questions?
No,
So take that off for me, and then we're going to go to the last part of the question where they said that we're supposed to determine the values of A, B, C, and D, given that 3A plus B inverse is equal to C. Mhm. Everyone is finished with the board?
So 1 second. Yes, sir. Finish.
Everyone is finished?
Yes, sir.
All right. So for the next part of the question, all right, so what I'm going to do is to remove this. Well, I didn't even have to remove the top section. Let's say for the fourth piece of the question, they said that we're supposed to determine the values of A, B, C, and D. Now, 3A plus B inverse is represented by this. Remember, we just worked it out a while ago? 3A plus B inverse is equal to this. So what we're going to do, we're going to let it equal to what? We're going to let it equal to C. So just remove this, and I'm going to rewrite all of this question, or all of this part here. So we have 3A plus 2, 3C minus 3. I don't really have much space, so let's do it like this. We have 3A, 3B minus 3, and 3D plus 5, and it's supposed to be equal to C. It's supposed to be equal to C. Now, what was C? C was what? C was 14, 0, minus 9, and 5. That was C. So we are supposed to determine the values of A, B, C, and D, given that 3A plus B inverse is equal to C. Now, this is equality. I think that's the topic, equality of matrix. So what you would do, this is a 2 by 2 matrix. This is also a 2 by 2 matrix. So just like adding, when we're adding matrix, we would add the corresponding terms. A with A, B with B, C with C, D with D. So the same thing with equality of matrix. We're going to let 3A plus 2B equal to 14. We're going to let 3 yeah, sorry about the noise. Whenever I'm there, and I'm not going to usually hear so nice. So no, just be prepared for that. Wrong with them money and they hope a bike nice. All right, so first element is represented by A, this is represented by B, this is represented by C, this one is represented by D. Same thing goes for this, C. So the first element is A, second B, C for the third, and D for the fourth. So what we're going to do, let each corresponding element be equal to each other. So we're going to have 3A plus 2 equals to 14. And if you realize this becomes a linear equation. So we can simply solve this by collecting like terms. So we're going to have 3A. So this is positive 2. When it goes over the equal sign, turns negative. So we're going to have 3A being equal to 14 minus 2. So 14 minus 2 is 12. So 3A is equal to 12. We're going to divide both sides by 3. But remember, we're solving for A. So A would be equal to 4. So that's the value for A. Now, value for B, we're going to have 3B minus 3 equal to 0. I'm going to collect like terms. So I'm going to have 3B equal to 0 plus 3. Remember, this is a negative 3. When it goes over the equal sign, turns positive. So I'm going to have 3B equals to 3. Divide both sides by 3. I'm going to have B equal to 1. Next, we're going to solve for C. For C, we have 3C minus 3 equals to minus 9. So I'm going to collect like terms again. So we're going to have 3C equals to minus 9 plus 3. We're going to have 3C being equal to minus 6. divide both sides by 3, we're going to have C equal to negative 2. So that's the value for C. Now the value for D is, so we're going to have what? 3D plus 5 equal to 5. We're going to collect like terms. So this is a positive 5. When it goes over, it turns negative. So I'm going to have 3D equal to 5 minus 5. So we're going to have 3D being equal to 0. Divide both sides by 3. D is going to be 0. So those are the values for A, B, C, and D. A is equal to 4. B is equal to 1. C is equal to negative 2. And D is equal to 0. Does anybody have any questions? Does anybody have any questions?
No, just a refresh. Would you please turn the laptop to the left?
To the left?
Yes, I can't see
Your left arm?
A.
Oh, you cannot see A. Oh, so that means I would this direction.
Yes, thank you.
All right. So well, more than likely I'm going to have to switch it back. So just right from this section, go to that side, and I'll adjust the camera as you write.
Sir.
Yes, miss.
Sir.
Yes, miss. I'm here now.
Sir, when you say it should be equal to 3, what's supposed to be the same value?
Same value for C.
I see. So I thought that answer for A would be 14, B would be 0. So
no, man. No. But you understand what I did do?
Yes, sir, I understand, but I just thought that you would get back the same answer.
No, man.
Like the 14 is 0.
Well, if we substitute each value for the variable that we just solved for into this, we would get C, all the values in matrix C. Because if we, all right, B is 4, right? A is 4, right? So 3 times 4 would be 12. 12 plus. Do you see that?
Oh.
Yeah, and for B is 1. So 3 times 1 is 3. 3 minus 3 would give us the 0. That is how you'd actually prove that each of the values here are correct. So let me know when you're finished.
Sir.
Yes, miss.
Up where you have 3A plus 2.
Yeah.
And so on. Why did you simplify it?
No, man, you cannot, if you realize right here, 3A plus 2, you cannot add those together. You cannot add. So, for example, we have A plus A. Same A, we could add them because they are like terms. So that would be 2A. Now, if we have A plus B, we cannot add A and B together because they're unlike terms. Just like if we had A plus, we cannot add them. Understand what I'm saying? This is considered to be a binomial. You cannot add those two terms because they're unlike terms. If we had an A attached to the 2 now, we could say yeah, because this A would be represented by a 1A and this would be 2A, so we could add these. But without, and it depends on the type of A as well. Because if we have one capital A here and one common A there, we cannot add them. Because they're two different A's. Understand, miss? So we cannot simplify 2 plus K, for example. We cannot simplify that because we cannot add 2 and K. Understand? We cannot simplify these unless if we were given some values for A, B, and C and D, we could simplify it by substituting the whatever value that was given. But in this case, in this format, we cannot simplify it more than how it is. And that will be the conclusion for this question. So we're going to move on to another question. Everybody's finished the board?
No, I cannot see the last one.
Oh, that's D. D. All right. So I'm just going to switch it down like that. Seen it now?
Oh, I guess you already work it out. All right, thanks.
Yeah. That's a good man. Work it out.
Sir, go some more for me, please.
Over?
Towards
Okay.
D.
No. Towards D.
Yeah. Look a bit more.
Is that okay?
Yes, sir.
But I'm not sure why you're not seeing everything on the board when I'm seeing everything on the on my screen. And one next thing, try and unmute your mic and just say no or yes or if you're asking a question, because sometimes I'm not paying attention to the chat. All right, so can I clean the board now?
Yes, sir. Yes, sir. Yes, sir.
All right. So what we're going to be looking at now is inverse and solving simultaneous equations using the matrix method. But what I think I might do is make up a question and then put it in the matrix format so that they can have an idea of how to change a simultaneous equation into its matrix form. Okay, so I might do that before I start the question, because as I said, I'm just going to go through past paper questions. All right. So, say for example, we had a simultaneous equation, 2x, let's say 7 for example. But I just made up this question, so I try to solve it. Now, usually in the exam they would say like the pair of simultaneous equation, like in a layman's term, put it in its matrix form, and they might give you the form as ax equal to b, or they might say px equals to q. Now, A represents a 2 by 2 matrix, X represents a 2 by 1 matrix, and B represents a 2 by 1 matrix. Now, just as you see the values on the in the format of the simultaneous equation, that's how you would actually put down the values in the matrix form. Now, what do I mean by that? As I said, A represents a 2 by 2 matrix. So you'd have 2, 3, 1, minus 1. So you'd have 2, 3, 1, minus 1. Now, x represents the variables in the simultaneous equation, which is x and y. So x comes before y, so you're going to put x at the top, y at the bottom, equals to b, which is a 2 by 1 matrix, which is the what each equation is equal to, which is 5 and 7. So this is how you represent the simultaneous equation in its matrix form. Everybody get that? Everybody?
Yes, sir.
Yeah. So that's, just remove this one. So that is how you represent a simultaneous equation in its matrix form. So,
Remove it, sir.
huh?
By removing it, I was writing it down.
Oh, but I see same thing this, it's just that they use different letters. Get that? This is the same thing, it's just that they use different letters.
Can remove it now, sir. Thank you.
Yeah. All right, so I'm going to go into the question now. I remember the objective is to understand, not know. Try and understand based on the questions that we're doing. So, all right, so with this question, find the inverse of the matrix. Find the inverse of the matrix M, which is equal to 2, 1, minus 1, and 3. So they want us to find the inverse for matrix M. So remember, the inverse for matrix is equal to 1 over its determinant multiplied by its adjoint, ADJ for short. Everybody get that? No, so we're going to find the adjoint. Sorry, we're going to find the determinant. So the determinant is equal to AD minus BC, which is, so remember, this value is A, this is B, this is C, this is D. So we're going to have 2 times 3 minus, open bracket, 1 times minus 1. So we're going to have 2 3s, 6. Now, 1 times negative 1 is negative 1. But if you realize right here, we have 2 negative signs and they're multiplying by each other. So we're going to have positive 1. So the determinant is 7. Now, for the adjoint, or ADJ for short, as I said, what we're going to do, we're going to switch the values in the leading diagonal. So we're going to have 3 up here, 2 down here. And we're going to change the signs on the values for the minor or non-leading diagonal. So the 1 up here is positive, so we're going to change it to negative. And the 1 down here is negative, so we're going to change it to positive. So that would be the adjoint. So we can say M inverse is equal to 1 over 7 multiplied by 3, 1, minus 1, and 2. So what you would do, the scalar multiple is 1/7. So we're just going to multiply each term. We're going to multiply each term inside of the adjoint by 1/7. So we're going to have 3 over 7 minus 1 over 7, 1 over 7, and 2 over 7. Everybody understand that? Let me bring down the camera down a bit. Everybody understood that? So remember, it's 1/7 times 3, 1/7 times negative 1, 1/7 times 1, and 1/7 times 2. And remember, when you're multiplying a whole number and a fraction, so let's say, for example, we have 5 multiplied by 1 over 9, for example. This 5 has a denominator of 1. So what we would do, we would multiply numerator with numerator and denominator with denominator. So we would have 5 over 9. And as you can see, 5, there is no number that can go into 5 and 9 without leaving a remainder. So that is how you would work that out. Just leave it as a proper fraction. Any questions? Any questions?
No, sorry.
So that's just the first part of the question. And there's a second part to it. There's a second part to it. Second part for 4 marks. So find the inverse is easy, 2 marks. Sometimes, well, depending on the numbers, they might give you even 1 mark for it because it's very, very simple. And CXC is expecting that you'll be able to they can calculate the inverse of a matrix. They might give you 1 mark for it. Can I clean the board?
Sir, no. I'm finished.
Everyone is finished?
Yes, sir.
All right. So for the what's going on here?
Yes, sir.
Yes, miss.
In our previous working life,
Yeah.
where I had 5-3 and 3-2,
5, 3,
but
3,
then
2.
when you yeah,
5,
but
3,
then when
3, 2. Yeah.
but then when you switch around it became -3 and -3, right?
Yeah.
But then you know, you only have 3-1 and -1
And
and 2.
yeah.
Is it because negative is all here? They wouldn't put a -1 like where the positive one is.
No man, I did not switch the values, So don't think that I switch is what that is what I did. I did not switch the values. What I did was change the signs. So with this one, the one that I did before, diagonal, I'm going to change the signs on the values. So because they're already positive, I have to change both of them too.
I'm not
Oh, you're not seeing it? Oh, yeah, seeing it now?
oh, yeah.
Yeah, so remember, for the leading diagonal, what I did was to switch the values. Switch, change place. So I'm going to put the 2 where the 5 was and the 5 where the 2 was. Now, for the non-leading diagonal, what I did was to change the signs on the numbers. So both, if you realize, both trees are positive, both of them positive. So what I did was to change them to negative. So if, say for example, what if they were both negative? I would have to change both of them to positive. Now, what if one was negative and one was positive? The one at the top was positive, one at the bottom was negative. I would have to change the one at the top, which is positive, to negative, and the one at the bottom, which was negative, to positive. Understand what I'm saying? But let me give you another example with numbers that are not the same, because if you realize that the non-leading diagonal, both are number them are 3. And with this one, the non-leading diagonal, both of them are 1, it's just that the sign is a bit different. So let's say we had a matrix and we had 9, 7, 8, and let's say 2, for example. And we're finding the adjoint for this, the ADJ. We're finding it. Now, remember what we're going to do for the leading diagonal, we're going to switch values. We're going to change place with the numbers. So we're going to have 2 at the top, 9 at the bottom. Now, for the numbers, I have to change the signs. That's for the non-leading diagonals. I would have -7, -8. Why? Because both of them are positive. Understand? Now, what if, so I'm going to erase this now. Yes, Miss Brown.
For the non-leading diagonal, what if if the 2 of them is negative, sir? You're going to change one of them?
No man, change 2 of them. I did an example a while ago, so probably I moved too fast. So if both of them if both of them positive, we change both of them to negative.
Yeah.
If both of them negative,
Yes.
if both of them negative, for example, let me switch them like that. So if both of them negative, both of them is going to be positive in the adjoint. Now,
Okay.
what if we had a -7 and a +8? What I would have in the adjoint is a +7 and a -8.
Yes, sir.
Understand? Because I'm just changing the signs. If the 7, so for example, the 7 was positive and the 8 was negative, what I would have in the adjoint is a -7 and a +8. Understand? So basically what I'm doing is just changing the signs. So does that answers everybody's question?
Yes, sir.
All right.
Yes, sir.
All right. So what I'm going to do, I'm going to erase this and move on. So we're going to continue with the second part of the question. The second part of the question says you're supposed to do what? Calculate the values. Calculate the values u of x and y Where is it? Where's the question? Where's the question? For which m open bracket x and y is equal to 12 and 1. Everyone is seeing the question, right? So this is the second part of the question. It's a calculate the value of calculate the values of x and y for which m times x and y is equal to 12, 1. Now m, remember that m represents what? M represents the 2 by 2 matrix. So m would represent the 2 by 2 matrix. So the 2 by 2 matrix that was represented by m was what? 2, 1, minus 1, and 3 times x and y equal to 12 and 1. Now, what does this resemble? This not look like a simultaneous equation they give you. But it's just that they give you a different way to try to confuse you. Get what I'm saying? They give you in this format to try and confuse you. So, but once you understand what you're doing, it doesn't matter how they send the question, you will be able to see through whatever disguise they put forth. So, to solve, is that okay?
Yeah. Yes, sir.
All right. Now, to solve a simultaneous equation using the matrix method, what you would usually do is to find the inverse for the 2 by 2 matrix, which is this. Now, we have already calculated the inverse. Well, just this alone. So we have already calculated the inverse. So to determine the values of x and y, what we would do, or me in high school, say, we will multiply both sides by the inverse. No, you don't have to. You don't have to multiply both sides by the inverse. To determine the values of x and y, what you would, now, if we should multiply the left-hand side by the inverse, m times m inverse is equal to the identity matrix. I'm going to prove this in because I think I see it on some of the past questions. So a matrix times its inverse is equal to the identity matrix. I don't know if you know go and watch the videos, you know, but the identity matrix is 1, 0, 0, 1. So a matrix times its inverse is equal to the identity matrix. So once we know that, all right, multiplying the inverse by the left-hand side is going to give me the identity matrix with x and y. We don't have to do that because what did they ask us? They asked us to calculate the values of x and y. So what you just do, just multiply the right-hand side. I'm going to clean the board and I'm going to show you what I'm talking about. I'm going to remove this. I'm going to erase this. Hopefully everybody wrote that off. And I'm going to...
Sorry, then the answer be to find the inverse part.
Yeah, man, that was the first part of the question. Yeah, that was for 2 marks. Now, I'm just going to put everything on up here and do it in order so that you can see what I'm doing. I'm going to erase this. So remember, the 2 by 2 matrix that was represented by m was 2, 1, minus 1, and 3. So I'm going to write a bit smaller so that everything can actually fit, equal to 12 and 1. Now, as I said, m inverse, we calculated it just now. It's equal to 3/7 minus 1/7, 1/7, and 2/7. So, as I said, what we're going to do, we're going to multiply the right-hand side by the inverse of the matrix. So what we're going to have, so remember, if we should multiply both sides by the inverse of the matrix, we're going to have 3/7 minus 1/7, 1/7, and 2/7 here. What we would get on the for the left-hand side here is the identity matrix, which is 1, 0, 0, 1. X and y. Now, on this side, what I'm going to do, I'm going to multiply it by the inverse as well. But this is a typical mistake that students do. Now, if I'm going to multiply the right-hand side by the inverse, look, let's check and see what's going to happen if I should set it up like this. Let's check and see what would actually happen if I do it like this. Now, the first matrix here is a 2 by 1 matrix. 2 by 1, remember that's the order. And we're going to multiply it by a 2 by 2 matrix. Now, is these two matrices as they are they conformable? Can we multiply them? Based on the explanation that I gave you last class.
No, sir.
Why,
No, sir.
why can't we multiply them?
Because the 1 and the 2 will give you
The 1 and the 2, they are
they are not the same.
they are not the same. So remember, for two matrices to be conformable, the number of columns in the first matrix has to be equal to the number of rows in the second matrix. And they're not the same, so we cannot multiply them. So what we have to do, we have to put the inverse at where? At the front. Everybody get that? You have to put the 2 by 2 matrix at the front for them to be the same. So I'm going to remove this. So if I'm going to multiply both sides by the inverse, I'm going to have to put the 2 by 2 matrix at the front, which is the inverse. I'm going to have 3 over 7 minus 1/7, 1 over 7, and 2 over 7, and we're going to multiply it by 12 and 1. Now, let's see if this is conformable. So we have a 2 by 2 by a 2 by 1. So now we can multiply them because they're the same. Everybody get that?
Yes, sir.
All right, so let me take this out. So what I'm going to have is equal. So when the multiplying matrix is first row by first column, so it's first row or row by column. So first row by first column. So we're going to have first with first, second with second. First with first, second with second. So we're going to have, open a bracket here. So I'm going to have, so remember, another thing before I even start multiplying, 2 by 2 multiplying by a 2 by 1. So to check if it's conformable, check the middle numbers there, and the result is going to be, the order of the result is going to be a 2 by 1. So the result that we get should be a 2 by 1 matrix. So let me take this out. Remember, I need everybody to understand what they're doing. So we're multiplying. So it's first with first, second with second. So we're going to multiply 3 over 7 multiplied by 12 plus 1/7 multiplied by 1. Then we're going to have, so we're finished with the first row and the first column. We don't have another column to multiply the first row by. So we just move on to the second row, first column. So we're going to multiply second row, first column. So it's 1/7 times 12 plus 2/7 times 1. Any questions before we continue? Any questions before we continue?
No, sir.
Equal to, so what we're going to do, just multiply and then add. That should give us our result. So we're going to have, so remember the denominator for this 12 is 1, the denominator for this 12 is 1, the denominator for this 1 is 1, the denominator for this 1 is 1. So once we cannot cancel, remember when you're multiplying fractions, we always check the diagonals or the verticals to see if we can cancel. We cannot cancel anything. So what we're going to do, 3 times 12, that's going to give us what? 36. So it's 36 over 7 plus 1 over 7 times 1 is just 1 over 7. We're going to have here 1 over 7 times 12. That's going to give us 12 over 7 plus 2 over 7 times 1. That's just 2 over 7. What I'm going to do, I'm just going to write the answer here. As I said, the board space is limited. So the denominators for both fractions here are the same. So we can just go ahead and add the numerator. Everybody get that? We can go ahead and add the numerator. So 36 plus 1, that's going to be what?
37, sir.
Oh, 37 over 7. And here,
14 over 7.
14 over 7. Can we break it down any further?
14 over 7.
So what about the 37? Oh, excuse me 1 second here.
Second, second one. 14, 14, 7, 14.
Just excuse me 1 second. All right, yeah, sorry about that. So 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 37 over 7. Can we break down that any further?
No, sir.
So it's just 37 over 7, and this is what 2.
Over.
So those would be the solutions for, well, 2 over 1 is the same thing as 2. So that would be the solution for x and y. 37 and 2. 37 over 2, 37 over 7 and 2. So the value for x is 37 over 7 and the value for y is 2. Everybody get that? All right. Hold on. Hold on. Right here. Right here. As I check it over mentally, I realize I made a mistake right here. Now, negative 1 over 7 times 1. Where did the negative sign go? I said to myself, why may I get this answer and it can't break down? So, negative 1/7 times 1, that's going to give us, right here, we should have negative 1/7. Everybody sees that?
Yes, sir.
Yeah, man. And you can correct me too, I will never see it neither. Yeah, man, sometimes I write, I go to a little bit too fast. I left off the negative sign. So right here is negative 1 over 7 times 1. This should be negative 1 over 7. So instead of having that, we're going to have 35 here. And we're going to have 5 here. 7, 5, 35. Yeah, so those are the answers. So you see one little mistake can do? Just by leaving off the negative sign, get a total different answer. So that would be the answer though. So yeah. Any questions? Any question? Could you repeat that, miss? What, to that side? All right. So we have some more questions to go through, a lot more. So as I said, we're just going to continue with matrix, finish off matrix this evening. Next tomorrow what? Tomorrow Friday evening with lectures. So what you could do also, if you see any matrix question that you don't really understand, you can also send it to me. I'll work it in class. Or any other question for that matter. Everybody get that?
Start at the same time, sir.
Yeah, man. 5:30. Between that time. If I'm not going to have any class, I'll let you know. Or you won't see any link. You won't see any link. Could you repeat that, miss?
I'll be at work. I'll just take my lunch time that time.
Sir? Mr. Deman,
Yes, miss.
what time is class on Sunday?
Same time.
5:30?
Yes. Well, I say 5:30. Sometimes I think Sunday I logged on 5, but I didn't start until 5:30 because some students, well, I didn't really have enough to start. Just wait until we have probably about 30 at me start. So at the same time. But on Fridays we'll be working out multiple choice questions. So the questions are sent in the WhatsApp group. What you can do, I don't know.
Yes, sir.
Probably can print them off or something.
Okay, sir.
Yeah. So on Fridays, multiple choice. Sundays and Thursdays we will just continue with the written paper questions. So I'll just work.
Okay, sir.
Yeah. So I have a book here that I'm working from, so I'm just going to work questions from it. Yes, miss.
Okay, sir.
Yes, seeing that it's so many multiple choice past paper,
Yeah.
if you could just decide on which one you're going to do Friday, it would be better. But for me, I don't know about Sunday.
Is it decide?
No, yes,
Is
The
it,
money business.
is it this side one? Me just come on, me say, all right, here, we'll work that one. And I like to me plan out anything, me just say, all right. Me just start. You get to me, I say, me just act. That's the thing with me. You get to me, I say, I might come on the first one, me book up and me just say, all right.
That you're spontaneous, sir.
So,
But if you could just identify one.
I would have heard them in.
All right, sir. Forget about this, sir. If you could
I joke me
identify
already.
one,
I
and
joke me
then,
already, them, man.
we could just print it
Yeah.
and just work with that one. So each week now would work a different one.
All right. So we have about how many? Well, I think if we work like two multiple choice a even, we should be able to can complete. So it's 2014, 2019. I'm going to get 2020. And I think they have one for 2020 January. I'm not sure. I have to go search that one. So what am I going to do? 2014, 2015. We'll work those two tomorrow.
Okay, sir. Thank you.
Yeah, 2014, 2015. So we'll work those two. The other Friday, it's what? 2016, 2017. The other Friday after that is what? 2018, 2019. So we'll get through a lot of questions. So 2 questions per evening. Per Fridays, I should say. All right, so can I clean the board now? Can I clean the board?
Yes, sir.
And one next thing, when the board look like so you can't really see it so good, make me know. You turn on the light. All right, so remove this. So we are solving simultaneous equation using the matrix method, calculating inverse and stuff like that. So with this question, there's a given that M is equal to 2, 5, 7, and 15. First question. There's a show that M is a non-singular matrix. This is show that M is a non-singular matrix. And to show that M is a non-singular matrix, what we would do is to determine its determinant. So the determinant of M, so remember, a singular matrix, the determinant is equal to 0. A non-singular matrix, you're going to get a value other than 0. So we're going to have AD minus BC. So remember, this is A, this is B, this is C, this is D. So what we're going to have 2 times 15.
Excuse me, sir. Can you put the camera up a bit, please?
Up. All right. Is that better? Is that better, miss?
Yes, sir.
So we have 2 times 15 minus 5 times 7. So we're going to have 30 minus 35. So the answer is going to be minus 5. So we can say, therefore, M is a non-singular matrix. Well, let's say show that. So we can say, hence, M is not a non-singular matrix. Hold on. No, sorry, hold on. M is a non-singular matrix. Sorry. M is a non-singular. So I'm going to repeat what I just said. So M is a non-singular matrix. Now, when M is a singular matrix, when M is a singular matrix, we would have gotten 0 for the determinant. Now we did not get 0, so hence it's a non-singular matrix. Understand? So they said show that M is a non-singular matrix. So obviously we're going to get an answer, whether it's positive or negative. Get what I'm saying? So we got -5. So therefore, M is a non-singular matrix. Remember, in a singular, the determinant would be 0. Non-singular, you're going to get an answer, whether it's positive or negative. So a non-singular matrix is not equal to 0, basically. Understand what I'm saying?
Yes, sir.
Yeah. So right at off, go to the second question. All right, so can I continue?
Yes, sir.
The second part of the question, they ask for the inverse of m. So they say write down the inverse of m. So m inverse, so remember, m inverse is equal to 1 over its determinant times its adjoint, ADJ for short. That's what I'm going to write, ADJ. Now we have just calculated the determinant, so we could just write negative 1 over 5. And for the adjoint, remember, for the leading diagonal, we switch the values. So it's 15 up there, 2 down here. And we're going to change the signs on these. So it's going to be minus 5, minus 7. What you're going to do is to distribute the 1/5 inside the bracket. So distributing the 1/5 inside the bracket, you're going to get what? You're going to get minus 15 over 5 minus 5 over minus 5. You're going to get minus 7 over minus 5. You're going to get negative 2 over 5. So what you just do is just break it down or simplify it. So you're going to get negative 3, positive 1, positive 7 over 5, and you're going to get negative 2 over 5. So that would be that would conclude the answer. We could leave it as this because it's a write it down. Could leave it as this, or you could just simplify it and just leave it as this. So anyone is accepted. Yes, miss.
Why you change it? Why change it 15 and it was not 25?
Because 5 into 15 goes 3.
But
5 into 7, I'll leave one decimal. So I really want to write down the decimal. Understand? 1.1.2.
so I
No, yeah.
think that
4, 1.4. Could you repeat that?
I'm getting some kind of mix up now. But I thought when you change the minor than
Yeah, figure out whatever you were mixed up with. Hello?
because normally I change the 5 and the 7. I put the 7 with the 5 and the 5 with the 7.
I sign it down in the
Remember, what we switch around is the leading diagonal, and we change the signs for the non-leading diagonal. So these we change the signs. These we switch them around, switch places with these values. So the 15 go at top, 2 go at bottom. We change the signs on these. You realize that's what I did? Yeah. So that was 2 parts to the question. So as I said, they said write down, so you could just write down this and leave it as the answer. You know what I'm saying? As I said, write down. So just write down this, leave it as the answer. Or you could just simplify it and give them this. Now, can I clean the board?
Yes, sir.
All right. So, the next part of the question, All right, so I'm going to have to erase all of this. I'm going to erase this side. Now, for the third part to the question, one, two, three, they said that write down the 2 by 2 matrix, which is equal to the matrix. Write down the 2 by 2 matrix, which is equal to the product of M times M inverse. So I'm going to reread the question. They say write down the 2 by 2 matrix, which is equal to the matrix product M times M inverse. So M times M inverse. Can anybody tell me what that is? Went through it about probably a couple minutes ago. When you multiply a matrix by its inverse, what would be the result of this matrix multiplication?
Identity matrix.
The identity matrix. And what is the identity matrix?
1,
1,
0,
0,
1.
Yeah, that's the answer. That's the answer. Didn't say calculate anything. They say write down. That's the answer. So once you know that the matrix times its inverse is equal to the identity matrix, that's just write down the answer. All right. So what they say with the next question. So the last question, by the way, I'm going to read and write it down for me. They said pre-multiply both sides. Pre-multiply both sides. That's for this question. Pre-multiply both sides of the following matrix equation by. So pre-multiply both sides of the following matrix equation by. I'm going to repeat again. Pre-multiply both sides of the following matrix equation by. After by, you're going to write M inverse. So what they want you to do is to multiply a matrix equation by the inverse of the matrix. So after writing down this, they have comma 2, 5, 7, 15 x, y equal to minus 3 and 17. To bring the camera across a bit so that everybody can see that. So there's a pre-multiply both sides of this matrix equation by the inverse. So to do that, what you do, this was the inverse that we calculated. So you just multiply both sides by it. So you're going to have minus 3. So remember, this is the answer. Yes, miss.
Why you have the 1 below the
It's not a 1, it's a comma.
inverse? Oh, okay.
Yes, miss. It's not a 1. It's a comma. So after that, you write this. So I'm going to write the answer. So the answer for that section, as I said, pre-multiply both sides by the inverse. So that's what you're going to do. This is the inverse. So you're going to multiply. So it's minus 3, 1, 7 over 5, minus 2 over 5. You're going to have 2, 5, 7, 15, x and y. And remember, when you're multiplying the right-hand side, you're going to put a 2 by 2 matrix at the front. So you're going to have equal to minus 3, 1, 7 over 5, 2/5 times minus 3 and 17. And that's the result for that part. And then they said, hence, there's a follow-up question to this one. They say, hence, solve for x and y. So write this out for me. Then they say, hence, solve for x and y.
Will you please turn to the right, my right?
And look here, no need to get some proper device so that you can see the board, because I still don't understand why some students will have problems seeing the entire board. What type of phone are you using, miss? Or what type of laptop are you using?
the Galaxy, it's in a small box. It's not big on the phone.
That's the problem. Probably.
True, sir, it used to come up big one time, but now it come up in our little box.
Yeah, me don't know. Me don't know where the problem be. It look like since an update you get.
It doesn't come up like when you do it online on Saturdays. It doesn't come up like that. This one comes up like a personal thing.
Click on the box. So tap the box. It will come up bigger.
No, it doesn't.
It doesn't. I mean, it did not. Okay. Seriously. All right, so everyone is finished. So let me erase here. So for the hence section, so remember for the hence section, you know, we're only going to solve that side. We're not going to solve this side. We already know that we're going to get the identity matrix for this side. So I'm just going to write it down here. So the answer for this side, we're going to have 1, 0, 0, 1 with x and y. Hold on. Now see the board, man. Everybody's finished with this side?
Yes, sir.
All right, so let me just bring the camera up for a few seconds. Bring it back up, so. All right, so after pre-multiplying both sides, there's a hence solve for x and y. Now, to solve for x and y, remember, we're not going to solve for the we're not going to multiply the left-hand side, because we already know that a matrix times its inverse is equal to the identity matrix, which is 1, 0, 0, 1. I try to write a bit small so that everything can hold here. X and y equal to 2 by 2 matrix, which is minus 3, 1, 7 over 5, and the minus 2 over 5 times minus 3 and 17. So I'm just going to erase over here. We can get the space. So it's going to be minus 3 and 17. So we can just go ahead and solve this. So we have x and y. So we're going to have first row, first column. So it's minus 3 times minus 3. That's positive 9. 1 times 17. That's just 17. That was first row for. Hold on. Everybody understand what I just did?
Yes, sir.
Because these things, I could actually do them in the head, you know, rather than write down the steps. So it's minus 3 times minus 3. That's going to give us positive 9. Then we have that was the first term times the first term, second times second. So the first term in the row times the first term in the column, multiply them, and then multiply row times column. So we get 9 plus 17. Then we're going to have to move on to, so we don't have any more columns. So we're going to have to move on to the second row, first column. So what we're going to have is 3 over 5 times negative 3. That's going to give me negative 21 over 5 plus what I'm going to have here. I'm going to have to multiply the negative 2 over 5 times 17, in which that's going to give me negative 34 over 5. Close bracket. Any questions? Make sure I understand exactly what I'm doing here. Let it process. So it's this times this, then this times this. And what I did, they cannot cancel numerator with denominator, so I just multiply denominator with denominator. Sorry, numerator with numerator. And same thing goes for here. Numerator with numerator. The denominator for this negative 3 is 1. The denominator for this 17 is also 1. So it's 7 over 5 times negative 3 over 1. So that's negative 21 over 5. And here, we're going to have negative 2 times 14. That's going to give me negative 34. 5 times 1, 5. Everybody understand so far? All right, so I'm going to have x and y being equal to, so 9 and 17. That's going to give me 26. And the denominators are the same here. So what we're going to do is to just add the numerator. Both numerator values are negative, so I'm going to add them. So it's negative 55 over 5. So we can just simplify this, we're going to have what? When we simplify this, we're going to have what? 26 and negative 11. Because 5 into 55 is negative 11. So that would be the answers for that for x and y.
Sir, can you put the camera over to the right?
Over to the right. Is that okay?
Yes, sir.
All right. Can I clean the board now?
No, sir. Just a minute. Yes, no, sir.
All right, everyone is finished? All right, so let's move on to another question. So with this one, hold on, this one looks like I want to do already. No, you know, it's a different question, but it's just that it's the same format they give the question in. All right, so let's find the inverse of m. We already work on example like this already, so I don't think we have to do that over. All right, so this one, they said that given that the linear equation, so given that the linear equations are 2x plus 5y equals to 6 and 3x plus 4y, 3x plus 4y is equal to, this is what, 8, is equal to 8. They say write the equation in the form, ax equal to b, where ax and b are matrices. So they want us to write the simultaneous equation in the form ax equal to b, where ax and b are matrices. So to represent this in matrix form, as I said before, this is a 2 by 2 matrix, this is a 2 by 1 matrix, and this is equal to 2 by 1 matrix. So as I said, just like how you see it written down, x before y. So 2x plus 5y, 3x plus 5y. Now, if there's, well, I haven't seen a question with that, as in with CXC actually giving the y value before they give the x value. But if they write it like this, for example, what if they had it like this? 5y plus 2x, 4y plus 3x, and this is equal to 6, and this is equal to 8. No, you have to be careful of that. Why? You'd have to be careful of it. The y comes first. You wouldn't just write it down as you see it. Why? Because the y comes first. You have to make sure that the x is coming first. Everybody get that? Make sure that the x value comes first. Well, not really the x value, but the x term here. Make sure that it comes first. Everybody get that? Yeah. So I haven't, I didn't really try that with that type of trick there still. But if they go in the exam, say they want this matrix form and 5y or any one of the y terms come first, switch it around, but make sure that the x comes first. Everybody get that? Yeah, I was going to do that yet still. But if it comes like this, just write the values as they are. 2, 5, 3, 4, x and y, 6 and 8. That's the matrix form. Finish with that? All right, so let's move on to the second part of the question. Let's say calculate the determinant of A, of matrix A. So they want the determinant for matrix A. So I'm going to erase this. They want the determinant of matrix A. So A was equal to 2, 5, 3, 4. They want the determinant. So determinant of A is equal to AD minus BC. So remember, A is this element, B is that element, C is that element, and D is that element. So we're going to have 2 times 4 minus 5 times 3, which is equal to 8, minus 15, which is equal to negative 7. So that's the determinant of A. Take that off quickly for me. That's the determinant of A. Finish?
Yes, sir.
All right. So with the next part, they want us to show that. So I think I'm going to do the next part on this side. They said show that A inverse is equal to minus 4 over 7, 5 over 7, 3 over 7, and negative 2 over 7. So basically, they gave us the answer. So all we need to do is to just show them that that is the answer. So they want A inverse. So they say show that A inverse is equal to this. So that means we have to find the inverse. So A inverse, so our answer. So A inverse is equal to 1 over its determinant, which is, but the determinant was 1 over 7, negative 1 over negative 7. Well, it doesn't really matter where you put the negative still. So it's 1 over 7, negative 1 over 7 times its adjoint. So you're going to have to determine the adjoint. Now the adjoint, remember what we're going to do? For the leading diagonal, we're going to switch the values. So I'm going to have what? 4 there. And I'm going to have 2 down here. Then for the minor diagonal, we're going to change the signs. So I'm going to have minus 5. I'm going to have minus 3. Now to conclude this, what I'm going to have to do, the matrix product. Do a matrix product here, so I'm going to have to multiply each element in the matrix by the negative 1/7. So I'm going to multiply. So I'm going to have 1 times 4. We're going to have minus 1 over 4 over 7. Right here, negative times negative is going to give me positive. 1 times 5, that's going to give me the 5 over 7. Then here, negative times negative is positive, so I'm going to have 3 over 7. Right here, 1 times 2 is 2, so we're going to have negative 2 over 7. So that concludes our answer. You realize it's the exact same thing that they had. So, see there? So, hurry up and take that off for me. Let us continue the same question, as it's not finished. These questions are a bit long than usual. We have good amount of questions leaving. Good amount. We have like, let me see, we're here now. So,
Sir, what year paper is?
this one is 2007. Yeah. So, and these questions are a bit old in a sense. So when you're going through, but these should give you ideas of how to solve the earlier questions. Understand? So, if you're going through an earlier question and you see a question that you don't really understand, you can, as I said, when you come to class, you can always ask. But the questions are usually along this line. And if you realize, based on the question that you worked so far, all of them are basically the same thing. It's just that they might set it one different, little bit a different way, but all the questions are the same, and they're asking for the same thing. It's just that the numbers are different. So can I erase this?
Yes, sir.
All right. So the next part of the question, listen to what they said. They said using the matrix A inverse to solve for x and y. The last question, so using A inverse to solve for x and y. So using A inverse to solve for x and y. So if you remember, with the first question, they asked us to put the simultaneous equation in the matrix form. And what we got was 2, 5, 3, 4, x, y equals to 6 and 8. That's what
Equals 6 and 8.
That's what we got. So now they're telling us to use A inverse to solve for x and y. Now, A inverse is this. So all I'm going to do is to just multiply this side by A inverse. Because in this side, the 6 and the 8 by A inverse, that's going to give us the result after we work out everything. So what we're going to have, I'm going to have 1, 0, 0, 1, x and y being equal to the 2 by 2 matrix at the front. So I'm going to erase this. So the 2 by 2 matrix at the front. Just give me a few seconds. All right. Sorry about that. So we're going to multiply. So we're going to have minus
Sir,
4.
you can just
Yes, miss?
no. Me that ask if you can just the second part that you're writing. If you could just rub it out and start. My internet sorry, just it not chipping and chip out. So we never see it the second one. We have the 1 0, the 0 1. If you could just put that back from here.
No, man, I did not do anything here. This was the question. They say using A inverse to solve for X and Y. So what we had here was the first question. Remember the first question they asked us to put the simultaneous equation in matrix form?
Yes. Yes.
Yeah, so
Yes.
all I did was to rewrite it. Now, because I know that using the inverse to multiply both sides, multiplying the left-hand side, I'm going to get the identity matrix, which is 1 0 0 1 with the variables x and y, and it's going to be equal to the inverse times what the equations were equal to, minus 2 over 7 times 6 and 8. That's all I'm going to do, and then I'm going to multiply this and then solve for
It's negative 6.
negative. Hold on.
6.
No, man, it was 6. It's
Sir, negative 6 to true.
that where here.
Sir, that me
Why here?
2x. Sir, before you write.
Yes,
Yes.
sir.
Sir, you did have 2x plus 5y
Yeah.
minus 6.
No, man, that should be equal. That should be equal. No, man, equal. It should be equal. Maybe it's because I write the two lines too close to each other. But it should be equal. Do you get that? All right, so now we can just multiply this, or because that part should be simple. That part should be simple. And what I'm going to do, meanwhile, I'm going through the book. Any question that looks like one that we do before, I'm just going to skip it. Because they're basically doing the same thing over and over. Finding the inverse, then finding the determinant, or find the inverse, then multiply both sides by it. We're doing the same thing over and over. So that doesn't really make much sense with us to do that over and over. I'm looking through the questions, and it's the same questions over and over. So this one, they said put it in matrix form. This one, they said show that R is a non-singular matrix, in which you know that to find the determinant, once you get a number other than 0, it's non-singular. Then they said write down the inverse. You already know to do that. They said show that R inverse is equal to I. Everybody should be able to do that because a matrix times its inverse is equal to the identity matrix. And then they say using the matrix method, solve a pair of simultaneous equations. Simple something that you just multiply the right hand side by the inverse to get the solution. This one, put it in matrix form, ax equal to b. We did that already. Hence, calculate the values of x and y using the matrix. Yeah, so that we did that. So the questions in the book here, they're asking the same things over and over. Everybody get that?
Yes, sir.
Yeah. It's the same questions over and over. So that don't really make much sense. Hold on. Look, this one looks. Hold on. This one looks interesting. All right. So let's look at this one. So I'm going to allow you to write this one on your own. Okay. Everybody get that? Understand what I'm saying?
Yes, sir.
Yeah, man. So this times this plus this times this, and then you're going to have this times this plus this times this, and just work it out. So I'm going to skip to another question. We're doing the same questions over and over and over. All right, now this one looks interesting. This one. So I'm going to, well, same thing we're doing over and over. So I'm just going to do the entire thing. So they said M is equal to the third part to it. Look interesting though. They said M is 2, 1, 4, and 3. That's what they say matrix M is. They say evaluate M inverse. So they want the inverse of M. So the inverse of M. M inverse. That's what they want. So the first thing we're going to find is the determinant, which is AD minus BC, which is equal to 2 times 3 minus 1 times 4, which is 6 minus 4, which is equal to 2. Then we're going to find the adjoint, ADJ for short. So the adjoint, we're going to switch the values in the leading diagonal. So we're going to have 3 and 2. And we're going to change the signs on the values in the non-leading diagonal. So we're going to have minus 1, so it's 3 here, minus 1, and minus 4. And don't tell me so that one there, what is that? 7. It's 1. This is 1. So M inverse is equal to 1 over 2 times 3 minus 1 minus 4 and 2. Everybody get that? Everybody understands that? So that was the second,
Yes, sir.
that was the first part. The second part to the question, they said that show that M inverse is equal to I. And we already know how to prove this, because we're going to multiply what? The matrix by its inverse. So it doesn't really matter if we put the inverse first or the inverse last. It doesn't really matter. It's commutative. So we're going to write half 3 minus 4 minus 1 2 2 1 4 3. Can I erase this side?
Yes, sir.
All right, so hurry up and take it off for me, because I need this space.
Sir, over the right side, you just have the adjoint and that's it.
Right here? Yeah, just the adjoint. But here I showed the one where determinant times the adjoint part.
So, sir,
Yes, miss.
you just leave the M inverse just like that because they didn't say to solve. They just said to show.
No man, but you wouldn't necessarily, you cannot solve this. The only thing can be done here is to just distribute the half times each element in the matrix.
So if we leave it like that in the exam, that would be okay.
Yeah man, that's the answer, that's the inverse. The inverse of a matrix is equal to 1 over determinant multiplied by its adjoint. Yeah man. But if they said show that now, and if you realize that they multiply each term by the inverse, they just do that. Understand? Like the question that we did before. Understand?
Okay, so we need to pay full attention to the terms and show that
Well, you need to pay,
different from what we just had here, sir.
you need to pay attention to everything. So nothing is wrong with leaving it like this. But if you want to conclude it or break it down a bit further, you could just distribute. So you're going to have 3 over 2 minus 1 over 2 minus 4 over 2 what's that, 2 over 2, and then you just simplify it. So you're going to have 3 over 2 minus 1 over 2 minus 2 and 1. If you feel comfortable doing that, nothing is wrong with it. So I'm going to erase this side. It must be finished by now. I'm going to show you that the inverse times the matrix is identity matrix. So right, 2 by 2 matrix. So it's first row, first column. So I'm going to write the answer here. So 3 times 2, that's 6, plus 1, negative 1 times 4, that's minus 4. So that's first row, first column. Everyone is seeing that, right? That was first row.
Mr. Lemon, Mr. Lemon,
Yes, miss.
good evening.
Good evening, Miss
I have a
Spencer.
question.
Yeah?
I have a question not really pertaining to the maths. The screen, sir, like the thing is updating, so I can't get you big on the phone, so I can hardly see what you. How do I get it big? Can I get big?
Right here. Go in at the party spot to show you amount of people in the class.
Everything is on the screen for me.
Oh, so
Yes, but on the screen it's like that tell you how much person in the class. Like on my screen that's a 22 others. You click on that,
Yes.
and then wherever you see Mr. Nemard name come up, you click on that.
Alright.
Also, you pin it to the screen.
Me click on it, but it's still in a come up big. You just
Pin it to the screen.
Pin Mr. Nemard to the screen.
yeah, there should be a pin icon in the left, what, right or left hand side of the screen.
Most likely in the center.
Left? I'm not sure. As I said, yeah.
On my right.
Oh, it's on.
Child, I say you must spin this. What? Pin this and then we come up with.
You got it, Miss Man?
Tap Mr. Nemard's side or slide and you'll see the icons come up and a pin icon.
All right, Miss Spencer. May I try to get it recorded, so hopefully you will be able to watch it from the start. Okay? So I'm just going to continue. Because probably by 8, we just cut off class till tomorrow. Because I have a couple things to do in the night. So yeah. So right here. So we're multiplying. We're multiplying the 2 by 2 matrix. So what we have here is when we multiply the first row by the first column. So I'm going to multiply the first row by the second column. So it's 3 times 1, which is 3.
Okay, sir, let me see. But I'm not seeing everything on the board. I'm not seeing
Plus.
the left side. Please.
Plus negative 1 times 3 is negative 1. Are you hearing what I'm saying, Miss Spencer?
Yes, sir, I'm hearing you now.
Yeah, I'm saying that I think it's recording. So after class, you will be able to watch everything from the start. Okay? It's just that, yeah. So so that was the first row, first column, first row, second column. So we're going to move on to second row and both columns. So it's the second row, first column. So it's minus 4 times 2, that's minus 8, plus 2 times 4, that is 8. So that's it for the second row, first column. So it's second row, second column. So what we're going to have is minus 4 times 1, which is minus 4, plus 2 times 3, which is 6. And remember the half. The half here, I'm going to bring the half here. So bring back down the half. I'm going to have 6 plus minus 4, that is 2. So remember, negative is stronger than positive. So here we have 3 plus minus 3, that is 0. We have minus 8 plus 8, that is 0. Minus 4 plus 6, that is 2. So when you distribute the half times each term, you're going to have 2 over 2, 0 over 2, 0 over 2, and 2 over 2. So when you conclude everything, you're going to have I, which is 1, 0, 0, 1. Everybody gets that? So we have completed the first and second part of the question. Now the third part that I said was very interesting. That's what we're going to look at now. It's not hard, but it's just that the way how to do it might confuse students. That's why I'm working this one. Then this one on this side looks a bit interesting, so we can solve this side also. And then we do that. We did something like this already. And then that's it for matrix. That's it for matrix. So as I said, when you're going through the past per question, because yes, miss?
Sir, I was asking if you could just put the camera over to the left.
That side?
No, sir, the next side.
Oh, so my right, your left. Oh, all right, that side. Is that okay?
Sir, what about transformational matrix?
Yeah, that me have to try cover one evening. I'm not sure which evening, but I try to finish up the normal matrix and vectors first.
Okay, I understand.
Yeah. Transformational matrix not hard. I think I have one video up on that already, so you can go and watch that one. I don't know nothing hard, basically the same principles then, multiplication. It's just we not calculate inverse. And you need to know them. I might do a video on how to on them before we actually like go through them with you one by one before we actually use them.
So, sir, you're recording this whole session?
Yeah.
As my miss can I pull up the first hour, so I wonder if you upload the channel.
Yeah, man, I record it, but I'm not sure about the sound though, because through them up money I read past every minute, like say. I don't know. So hope a sound are going out, so I'm not so sure how the sound, the quality I sound. Well, all right. Hopefully you'll see everything.
Okay.
Yeah. So Sunday we'll go on to vectors. I'm gonna try and see if we can record every class so that whoever miss it can probably see it. So after we finish, I think we just will spend one Sunday on vectors, because vectors not hard. Just try and find as much questions and work them out. Different type of questions.
Yes, sir.
Yes, miss?
You could record the Friday class. I would appreciate it because I have work on Friday. However, I'll take my lunchtime on the Friday. My 1 hour break during that time to see what I can.
Yeah, man. That's what the multiple choice?
Yes, sir.
Yeah, man. Me try and see what we can do.
Appreciate it.
All right. So for the last part of this question, I'm going to erase this. Going to erase this. Now, the last part of the question. Yes, miss? Want me to erase it too quick?
Yeah.
So write this down for me. Using a matrix method to solve for R, S, T, and U, R, S, T, and U, in the equation and this is the equation that I gave you. So let's say use the matrix method to solve this. Everyone is seeing the equation?
can see me.
Yes, sir.
All right. So they say use a matrix method. So can I hear from students what you would actually do? What would you do if you see a question like this? And they say use a matrix method to solve for RSTU. What would you do?
Two times.
2 times R, so you'd multiply this times this?
I'm just saying, sir, because I wasn't at the beginning of the class.
Oh, you just try something. All right, so the students that are here from the start, what would you do if you see a question like this? Because I need to know if I understand what I do how long, about how long me there now. From 5:30 until
AD
now.
minus BC.
AD minus BC. Oh, so you're saying we should calculate the determinant for this?
Determinant.
Does this resemble anything that was on the board before?
That's a multiplier. With
Sir, you never there for the close to half. But you can multiply the matching elements by the one another.
Oh, so you multiply this times this, that times that, this times this, that times that. No,
Yes,
sir.
sir. And the transposed.
No, sir. That's not what you're going to do. But hold on. Hold on. This don't look like something over there on the board before.
Sir, what about the inverse method?
What are you?
so that I first M.
Yeah, man, this is the first M.
First
So what they want us to do is to use the inverse to multiply both sides to solve for RSTU. That's what you're going to do, you know.
But I thought it was a separate question.
No, man, I told you that it was the third piece.
Part of it. Oh, it was part of the same.
Yes, man, I told you that it was the third part. I told you that the third part was very interesting, and I solved the first two, and this is the third piece.
It was a different question, sir. Sorry.
No, man, it's the same question. Remember when we just started the question, I said I want to look interesting. So this was the M. We calculated the inverse for it, and the inverse that we got was what? Half. What was half? 3, 2, minus 1, minus 4. So when we multiply the left hand side by it, what are we going to get for the result on the left hand side? So on this side, does it matter how I put the inverse or where I put it? Like, oh, this is a 2 by 2 matrix. Do you think it matters how I put the inverse or where I put it? No, but if it was a 2 by 1 matrix, it would have mattered. Everybody get that? But just the same, I'm going to put it at the front. I'm going to put it at the front because I don't want to go say me put it at the back and I confuse my head. So that is how you'd lay it out. And remember, when you multiply a matrix by its inverse, what do you get for the result? The identity matrix. So here you're going to have 1, 0, 0, 1. RSTU. So remember, we don't have to work out this side. We don't have to. Because we already know that we're going to get the identity matrix for the result. Equal to half bracket. So we're multiplying 2 by 2 matrix by a 2 by 2 matrix. So we're going to have 3 times 2, which is what? 6 plus minus 1 times 4, which is minus 4. That was the first row, first column. So move on to second row, second column. So it's 3 times 1, which is 3, plus minus 1 times minus 1. That's going to give us positive 1. Then we move on to second row, first column. So it's minus 4 times 2, which is minus 8, plus 2 times 4, which is 8. Then we're going to move on to second row, second column, in which we're going to have minus 4 times 1, which is minus 4, plus 2 times minus 1, which is minus 2. I'm going to continue up here. So all of this, I'm going to bring it up here. So what I'm going to have, I could just rewrite this 1, 0, 0, 1 R S T U equals to half open bracket so we're just going to simplify here. So 6 minus 4, that is 2. 3 plus 1, that is 4. Minus 8 plus 8, that is 0. Minus 4 minus 2, that is minus 6. So what you're going to have is 1, 0, 0, 1. R, S, T, U. Now, after distributing the half inside the bracket, what we're going to get? We're going to get 1, 2, 0, minus 3. Everybody should be able to know what I have done there. Then you can write, therefore, R equal to 1, S equal to 2, T equals 0, and what is this again? U equal to negative 3. Any questions? As I said, it's recorded, so you can go back and watch the video. Any questions? Any questions?
Sir,
Yes.
the bottom part
Yeah, we're here.
of what you just did, yeah, kind of looks like the one you did before. Is it just that the letters are changed or something?
Yeah, man. That's basically the same thing as a simultaneous equation using the matrix method. We had the only x and y here. But with this particular question, they had R, S, T, U.
Sir, can you please move the camera to the right, please?
That side?
Yes, sir. Just a bit more.
Is that okay?
Yeah.
Now, with there's something that I should explain. Why you have R, S, T, U. Actually, what it is that they have, instead of dealing with one pair of simultaneous equation, this is 2. Understand what I'm saying? Instead of dealing with one pair of simultaneous equation, this is actually 2 pairs. I would have to expand it back to show you. So hope I write this off, and I'm going to show you what I'm talking about. This is actually 2 pairs, not 1 pair, but 2. Excuse me for a few seconds. All right, so everyone is finished with the board? Everyone is finished with the board, right? All right, so let me show you what I was talking about when I said that this was actually 2 pairs of simultaneous equation instead of 1. So with 1 pair, you would have something like this. So say for example, we had 2x plus 5y equal 1 and 3x minus 8y equal to 7. So if we're going to put this in a matrix form, we would have ax equal to b, in which we would have 2, 5, 3 minus 8, x and y equal to 1 and 7. That is how we would put this in a matrix form. Now with the question that we had just completed, what they have had was 2, 1, 4, 3. They said RSTU is equal to 2, 1, 4, and minus 1. Now let's look at this. Let's expand this, because expanding this will show you what I'm saying. So first row, first column. So 2 times R would give me 2R plus 1 times T would give me T. Then I would have to move on to second row. So first row, second column. So it's 2 times S, which is 2S, plus 1 times U, which is U. So that would conclude the first row and the column. So move on to second row, first column. 4 times R is 4R, plus 3 times T would be 3T. And that's second row, first column, second row, second column. 4 times S would be 4S, plus 3 times U would be 3U. And it would be equal to 2, 1, 4, minus 1 equal. So what I would actually have is 2R, part this off here. So what I would actually have is 2R plus T equal to 2. We would have 2S plus U equal to 1 and 4S plus 3U equal to negative 1. So instead of dealing with 1 pair, this is actually 2 pairs. Understand? Everybody get that? So this is 1 pair, and this would be the other. This would be the other pair. It's a wonderful thing when you understand these things. You know? Yeah, man. When you understand questions like these. So I'm going to erase this, and I'm going to do another question that I see here. We haven't done anything like this yet, so we can solve this one. I think this is going to be the last one also. Yeah. What they have next in the book is transformational matrix. So we're not going to touch that as well. We have quite a number of questions on that. Then we'll move on to vectors. All right. So I'm going to clean the board. So remember, tomorrow we had what? Sunday we had about 40 students on the meet. Now we have 30. So tomorrow hopefully more students come. I don't know what's wrong with them because me continuously, but I don't know, they more blame COVID, yeah, man. I think COVID is a problem. So well, the part here and throw the water in night. A minus 4, 1, B. We have 2 minus 4, 1, and minus 3. Probably some persons have internet problems. Yeah, me understand that. Or probably not have access to internet.
Perhaps they're at work.
I understand that, but not so sure I go on, yeah, man. But me know say some of them, some just not interested. So we just have to, who interested, just come to class. Eh? So no nobody we don't know about it, just can't just tell them. So we just have to deal with this until exam because I realize we're kind of behind in terms of syllabus and we need the practice. Because some persons can't really practice on their own. One whole heap of other things. So with this question, they say calculate the values of A and B such that, so calculate the values of A and B such that this times this is equal to that. So let's work this question out. So what you're going to do, you're going to multiply the first matrix by the second one, let it equal to this one, the third one. What we're going to have is first row, first column. So we're going to have A times 2, which is 2A plus 4, negative 4 times 1, which is minus 4. That was the first row, first column. We'll move on to first row, second column. We don't even have to multiply the second row by the second column either, but I'm just going to do that and show you why.
So what's the question? Calculate the values of A and B such that,
and you just write this. Yeah. So you don't even have to multiply the first row by the second column. You don't have to. Because if you realize all you're going to have inside of it is A as the variable. But I'm just going to multiply it and show you that what I'm talking about. Sometimes it's best to show rather than just talk. So first row, first column gives me this. First row, second column, I'm going to have minus 4A plus 12. Because it's A times minus 4, it's minus 4A. And minus 4 times minus 3, that is positive 12. So that was the first row and the 2 columns. So I'm going to move on to the second row and the 2 columns. So it's going to be second row, first column. It's 1 times 2, which is 2, plus B times 1 plus B. That was the second row, first column, the second row, second column. So I'm going to have 1 times minus 4, which is minus 4, plus B times 3, which is minus 3B. And it's equal to 2002. Now, just like with equality of matrix, that's what we're doing. So we're going to let 2A minus 4 equals to 2. So 2A minus 4 equals to 2. So we're going to solve for A. So I'm going to collect like terms. So I'm going to have 2A equals to 2 plus 4. Remember, it's negative on this side when it goes over to turn positive. So I'm going to have 2A equal to 6. Divide both sides by 2. A is equal to 3. Now, if we write this one, if we work out this one, we're going to get the same value for A. Hold on. Sorry, just realized it's not seeing the bottom section of the board. So here, if we work out this one with the A as well, we're going to get the same solution right here. So let's see if we're going to get the same thing as I said. So it's minus 4A plus 12 equal to, it's equal to what? 0. So 0. I'm going to bring over the positive 12 to turn negative. So we have minus 4A equal to negative 12. Divide both sides by negative 4. A would be equal to 3. See it? Same value. Same variable, same value. So we didn't have to multiply the first row by the second column. Nor did we have to multiply the second row by the second column. We could have multiplied the first row with the first column and the second row with the first column, and we just use those two to solve for A and B. Understand?
so 160 you want us to show over, that would be
Yeah, man. But if you realize, it's the same variable in both equations. A alone. Understand?
Yes, sir.
Yeah. So it's just A only.
So that's why they have the same answer then.
So that's why they have the same answers. Get that? So solving for B.
So basically you wanted us to prove that
Not
what's on the left hand side is equal to what is on the right.
not prove. Not prove.
Or just to find the variable.
The values for the variables. A and B.
Oh, to find the okay.
So I'm going to solve it out just the same, I'm going to solve each of them just the same. So
So what you're saying is basically once you find A will be the same anywhere.
yes, sir.
And once you find B will be the same anywhere.
Yes, sir. That's what
So
I'm
what you
saying.
just substitute that into the formula and you're good.
Yeah, man.
Substitute it into the thing.
So A is 3. So 3 times 2, that is 6. 6 minus 4, that is 2.
It's 2.
Right here. Minus 4 times 3, that is negative 12. Negative 12
So
plus
3
12
minus 2.
gives us 0. So that means,
I get it now. I get it.
get that? So it's A is correct. So for solve for B, you're going to have 2 plus B equal to what? What is this one going to be equal to?
2 plus 3. I mean 2B.
So 2 plus B, what on this side is it going to be equal to? Remember, it's equality of matrix,
See, sir?
No.
Different.
So it seems like me thought back over everything then. All right. So let's go back over it. So they asked us to calculate the values of A and B, right? So they gave us a matrix product right here. So we have to multiply both matrices by each other. So what I'm going to do is first row by first column. So A times 2, that's going to give me 2A, plus minus 4 times 1, that's going to be minus 4. That was the first row, first column. Now first row, second column. A times minus 4, that's minus 4A. Minus 3, minus 4 times minus 3, that is positive 12. So that was the first row and the 2 columns. So we're going to move on to the second row and the 2 columns. So we're going to do it in order first. So it's going to be 1 times 2, which is 2, plus B times 1 is just B. So that was the second row, first column. So it's second row, second column now. So we're going to multiply 1 times minus 4, which is minus 4, plus B times minus 3 is minus 3B. And it's going to be equal to 2, 0, 0, 2. Now remember, the elements in the matrix are of a particular order. Now, the first element is represented by A, meaning all of this is represented by A. This one over this side is represented by A, which is the first element in. Remember, you know, both matrices are 2 by 2 matrix. Now, the second element in this matrix is B.
No, go ahead.
That's the form of a matrix. And when we say form, we don't mean order. Second element B, third element C, fourth element D. Understand what I'm saying? So the first element in this matrix is considered to be A. The first element in this matrix is considered to be A. If you realize both matrices are equal to each other, so I'm going to let A equal to A. And when I say A equal to A, I'm referring to what they're considered to be. Meaning 2A minus 4. 2A minus 4 is going to be equal to 2. Minus 4A plus 12 is going to be equal to 0. 2 plus B is going to be equal to 0. And minus 4 plus minus 3B is going to be equal to 2. Do you understand what I'm saying now?
Yes, sir.
Everybody?
Yes, sir.
Yes, sir.
Because obviously, if I have a 2 by 2 matrix on this side and a 2 by 2 matrix on this side, say, let's say we have P here, we have Q, we have R, and we have S. We're going to have A equal to P, B equal to Q, C equal to R, and D equal to S, because they're at the same position in each matrix. Each 2 by 2 matrix. Understand what I'm saying?
Yes, sir.
So it's the same thing when you're solving a matrix equation. All of this
Yeah, I get that.
represents the first
But what I was
element,
asking,
which
sir,
is A. Yes, sir.
what I was asking is that so that in terms of position, where 2 plus B would be C, or would be 0 in this case over here.
Yeah, it
What
would
I'm
be
asking is
equal
that
to 0.
how do we get 2 plus B to equal 0? That's the part I didn't get.
And that's what I just explained, because of the position. This one is in the what? The third position. This is also in the third position. This is in the third position. This is also in the third position. If you realize we have a variable here, we have a variable here. Now the only way to solve for this variable is to let it equal to this number here.
Oh,
Understand?
yes.
Now whatever value we get, when we substitute back into the expression here, we should get whatever value was here, which is 0.
Yes, sir.
So remove this. So what we're going to have 2A minus 4 equals to 2. So this becomes a linear equation, you know. So we're going to solve it. We'll collect like terms. So we're going to have 2A equals to 2 plus 4. Because this is negative, when it goes with the equal sign, it does what? Change sign to positive. So we are going to have 2A equal to 6, divide both sides by 2. A is equal to 3. And as I said before, if you should let this equal to this, you're going to get the same answer, 3. You don't have to do that. So you just let 2 plus B equal to 0. So B is equal to negative 2. Because if I bring this positive 2 over, turns negative, that's the answer. So the answer for A is 3, answer for B is negative 2. As I said before, just let this here equal to 2, you're going to get the same answer as what you got for the first one. So you don't have to work out that one. Understand?
Yes, sir.
Yeah. So that's it for this evening, okay?
Alright.
All right, sir. Thank you.
Yeah, man. So tomorrow.
God bless you.
Bless you, God bless me.
Tomorrow. All
Thanks
right.
very much, sir.
Yes, sir.
Thanks, miss.
Don't mention God to Miss Mars.
Eh?
Miss Mars.
We said don't mention. Why not? Hmm?
Remember say Allah you people.
Eh? Nah, man, I joke me around yesterday, man.
I know. Have a good night, everyone.
All right. So,
Alright.
so remember, no, man, because I same answer. We all get. So, me work it out, show you. We're going to get the same answer. So, if we have minus 4 minus 3b, we're going to let it be equal to 2. We're going to collect like terms. So, I'm going to have minus 3b equals to 2 plus 4, because this is negative 4 when it goes well, change sign. So, we're going to have minus 3b equal to 6. Divide both sides by minus 3. B is going to be equal to minus 2. Understand?
Yes, sir. Thanks.
Yeah.
Yeah.
So we're finished with matrix, you know. So Sunday we'll be looking at vectors. We're going to be looking at a lot of vector questions.
Okay, sir.
Yeah.
Okay, sir.
All right.
I can know a bit more of this, and Richard.
All right, Miss Spencer.
Sorry, sorry, your brother's listening.
No, man, that's all right. That's all right, man. That's all right. All right, Miss Spencer. Yeah, remember, I'm going to try and post the video so that you can go and watch it, okay? Any questions you have, you can just WhatsApp me.
Yes, sir.
Yeah. Yes, miss. Good night.
Night, sir.
Okay, miss. Give this video.